if you see a function inside, it's inside of another function, think chain rule. A function inside of another function is what we call function composition. Okay. So I'm going to call the outside function f. Okay. So let y equal, so f is going to be square root. So f is square root. So y is equal to square root, and I'm going to call this u. More on that later. And f was what again? F is square root of u. Okay. So I'm going to call the outside function f. I'm going to call the inside function g. Okay, so g of x is equal to 5x squared plus 2. But you'll remember from earlier, this was also u. Okay. Now what happens if I go to this equation and change all the u's to g of x? Well, okay, so we've got f of, this gets changed to g of x, so f of g of x is equal to square root of g of x, but that's the same thing as square root of 5x squared plus 2. So why did I use f and g? Because this matches with this. If I decompose, this is what we call decomposing. If I decompose y into two functions. Okay. So we can say that y is equal to f of g of x. By the way, whatever I write down here, you don't have to write down when showing your work. I'm just including it to elaborate a little on certain things. Okay, but y equals f of g of x. Now, according to the chain rule, what would y prime be equal to? So it's going to be derivative of outer times derivative of inner. Okay, And what is f prime? So if fu is square root of u, what would f prime be? Okay, so fu equals square root of u. I'm going to rewrite this as u to the power of 1/2, because raising to the power of 1/2 is the same thing as taking the square root. Now, if I wanted to take the derivative of this, what do I need to do with the 1/2? I need to move it in front. And then u gets raised to what power? I need to subtract 1 here. Okay, and how do I get rid of the negative exponent? So whenever we look for an expression in simplest form, basically to simplify this, you don't want to have negative exponents. And you can get rid of that by moving it to the denominator. Or another way you can write it is 1 over 2 root u. So that's what f prime is. Let's go ahead and add that to over here where we are showing our work. So this implies f prime of u is equal to 1 over 2 root u. Okay, so I used this one because we use square roots here, so we might as well use square roots here. Okay, so that's f prime. We might as well find g prime as well, right? Because we're going to use it in a second. Okay, so if g of x is equal to 5x squared plus 2, then what would g prime of x be equal to? Okay, so g of x equals 5x squared plus 2. How do I find the derivative? What's the derivative of 5x squared? What do I do with the 2? I move it in front. Okay, so this turns into 2 times 5x, and then what do I need to do with the 2 here? How much do I need to subtract? Subtract 1. Okay, and what is the derivative of 2? It's just 0? Okay. And anything raised to the power of 1 is just the number itself. What's 2 times 5? 10, and yeah, I just won't put the plus 0 here. Okay, so let's go ahead and write that down. All right, let's finish the problem. Okay, so y prime is equal to f prime, which is how much again? 1 over 2 root 1 over 2 root u, but u is g of x, and g of x is equal to how much? Is equal to 5x squared plus 2. Okay, and then times how much? How much should I put here? $10x. Okay. What can I cancel here? Okay, so I can cancel the 2 and the 10. Divide out 2 here, divide out 2 here. So y prime is equal to... So if I divide out 2 here, or if I divide out 2 here, this whole thing turns into 5x. So 1 times 5x. And then if I divide out 2 here, then this goes away. And we're just left with this. Okay, I should elaborate probably. Y'all can skip this if you know how to multiply rational, or if you know how to multiply these kinds of expressions, but okay, I'm gonna elaborate just a little bit more. Okay, so you can think of this as multiplying by 10x over 1, right? Because anything divided by 1 is just itself. And then we can cancel diagonally. So divide out 2. Okay, and there's nothing else we can cancel out, right? What's 1 times 5? Yeah, so basically, if there's nothing else we can cancel out, we go ahead and start multiplying. So 1 times 5 is 5. And then this is 1 times this. So it's just this times 1, which is just this itself. Oh, hang on. 5, it should be 5x, right? Yeah. Because we just divide by 2 here and here. We didn't touch this. Yeah, so it's 5x on top, and then root 5x squared plus 2 on the bottom. Okay, so that's your answer. And okay, so this is how to show your work.